It often feels like cybersecurity folks are in this constant arms race, doesn't it?
Oh, absolutely. You think you're secure, and then boom, something new pops up.
Exactly. So today, we wanted to dig into something more proactive, network hardening.
Yeah, getting ahead of the game instead of just, reacting all the time. It's about building stronger walls from the start.
Building stronger walls, I like that. And for this deep dive, we've pulled together quite a bit, readings on hardening itself, brute force attacks, cloud security, security tools, even some actual security reports.
Right. So the goal really is to give you some solid, actionable ways to beef up your network defenses.
Especially against those really annoying brute force attacks. We'll definitely focus a bit there.
Okay, sounds good. So maybe let's start with those brute force attacks then. To know how to defend, we got to know the enemy, right?
Good point. So brute force, at its heart, it's basically just trying everything, isn't it? Guessing usernames, passwords over and over.
Like trying every key on a giant keyring until one clicks.
Yeah, exactly. But it's not always just random guessing, is it?
No, not anymore. You have the simple kind, sure, just trying all combinations, A, B, C, 1, 2, 3. But then you have dictionary attacks. That's a bit smarter.
How so?
Well, they use lists of common passwords, maybe words from a dictionary, or even credentials leaked from other breaches. They start with the most likely keys first,
Ah, okay. Makes sense. And they aren't doing this by hand, I assume?
Oh, heavens no. They use automated tools, software that can just hammer away, trying thousands, maybe millions of logins super fast.
Right. Which really lowers the bar for attackers and makes it, well, much more likely they'll eventually get lucky if defenses are weak.
Precisely. Which brings us back to being proactive.
So before the attack even starts, what can you actually do? How do you find the weak spots?
Yeah, that's vulnerability assessment. Finding the holes before they get exploited. And two really useful tools here are virtual machines and sandboxes.
Okay, virtual machines.
Yeah.
VMs, right. They're like software versions of computers.
Exactly. You can run one on your actual computer, but it's totally separate, isolated.
So you can test dodgy files or code in there without risking your main system.
That's the idea. It's a safe little bubble. If something bad happens, it stays in the VM. You can just wipe it and start over clean. Super helpful for looking at suspicious stuff.
Is it perfectly safe?
Mostly. It's a strong layer. There's a tiny theoretical risk some really advanced malware could try to escape, but it's rare. It's generally a very safe way to test.
Okay. And sandboxes, how are they different?
Similar concept. Isolation is key. Sandbox is just a separate environment. Could be a VM, could be a dedicated machine. People often use them to test patches before rolling them out everywhere, or to simulate attacks safely, see how things hold up without breaking the real network.
Like a practice range for cyber defenses.
Kind of, yeah. But like VMs, some clever malware might realize it's in a sandbox and change its behavior, try to hide. So they're not foolproof, but very useful.
Okay, so we can test, we can probe for weaknesses. Now, how do we actively stop those brute force attacks? What are the key prevention moves?
Right, prevention. There's some really fundamental things. Let's talk salting and hashing first.
Salting and hashing. Sounds like we're cooking.
Yeah, a bit. It's about transforming passwords so they're not stored as plain text. Hashing turns the password into a unique, jumbled string of characters.
And you can't reverse it easily.
Exactly. It's a one-way street. You can't easily get the password back from the hash. Now, salting makes it even better.
Okay.
Before hashing the password, you add a unique, random bit of data, the salt, to it. So even if two people use the same password,
their stored hashes will look different because the salt is different.
Bingo. Which makes those pre-computed rainbow tables attackers use way less effective. They can't just look up a common hash value.
Ah, that's clever.
Well,
mixing a unique spice into each one, like you said. So stealing the hash password file is much less useful.
Much less useful. Much more work for the attacker for each password.
Okay, smart. What's next on the prevention list?
MFA. Multi-factor authentication. Or 2FA. Two-factor, which is a specific type of MFA.
Right. That's like when my bank texts me a code or I use my fingerprint.
Exactly. It means you need more than just a password. It relies on having two or more different types of proof. Something you know, like the password. Something you have, like your phone getting that code.
Or a little hardware token.
Right. Or something you are biometrics, like a fingerprint or face scan.
So even if they guess the password?
They still can't get in without that second thing. It's a huge barrier. Really effective.
Makes sense. What else?
Cap PTCH.
Oh.
And recap TCHA. You know those squiggly letters or click all the traffic lights things?
Yeah. The prove you're not a robot tests. Sometimes I'm not sure I can prove it.
Yeah. Yeah, that can be tricky. But the point is, they're designed to block automated bots, the kind used in high-speed brute force attacks, while letting humans through.
So they stop the automated tools from just hammering the login page?
That's the goal, yeah. They slow things right down for automated attacks.
Okay. And what about rules inside an organization?
Password policies. Really important. These are the company rules.
Like how long my password has to be?
Yep. Complexity rules needing uppercase, lowercase, numbers, symbols, how often you have to change it.
Mm-hmm.
Crucially, rules against reusing old passwords and account lockout rules.
What's that?
If someone tries the wrong password too many times, say 5 times, the account gets locked for a period.
So it stops a brute force attempt dead in its tracks after just a few tries?
Exactly. It prevents that relentless guessing.
Okay, so lots of layers just to protect the login itself. That leads nicely into this idea of defense in depth, right? More layers across the whole network.
Precisely. Defense in depth. The idea is no single defense is perfect, so you build multiple layers like a castle. If they get past the outer wall,
there's still a moat and guards and inner walls.
Got it. So we've talked about securing accounts. Now let's zoom out. What are the network level defenses?
Okay, what's layer 1?
Often it's the firewall, the gatekeeper. It looks at network traffic coming in and out and decides what to allow or block based on rules.
Like checking IDs at the gate based on source, destination, port number.
Yep, the basics. And next-gen firewalls and GFWs can look deeper, even inspect the content, the payload of the traffic for sneakier threats.
Okay, firewalls are the bouncers. What's next?
Then you might have an IDS intrusion detection system. Think of it like security cameras and motion detectors.
It watches for suspicious stuff.
Yeah, it monitors the network traffic, looking for patterns that match known attacks or just weird anomalous behavior, but it mostly just alerts you.
It detects but doesn't necessarily stop it, like a guard dog that barks but doesn't bite.
Good analogy. It raises the alarm. Now, an IPS intrusion prevention system can bite.
Okay, how does that work?
It also monitors traffic, like an IDS, but it's designed to actively block threats it detects. It can drop malicious packets, block the source IP.
It steps in automatically.
Right. The downside is, because it's in line with the traffic, if the IPS messes up, it could block legitimate stuff, a false positive, or even break connections if it fails. So there's a trade-off.
Okay. Firewall, IDS, IPS. That's a lot of signals and alerts. How do you manage all that information?
Good question. That's where sign systems come in. Security information and event management. Think of it as the central security control room. It collects all the logs and alerts from your firewalls, IDS, IPS, servers, applications, everything.
That fits it all in one place.
Yep, onto a single dashboard.
Yeah.
Tools like Chronicle from Google Cloud or Splunk are examples. It helps analysts see the bigger picture, correlate events, spot attacks, and respond faster.
So it connects the dots, but it doesn't stop the attack itself.
No, the SIEM itself is for visibility and analysis. The firewall, the IPS, they do the stopping. The SIEM helps you understand what's happening and direct the response.
Got it. Okay, so these principles apply everywhere, but things change when we move to the cloud, right? How does hardening work there?
It definitely changes, yeah. The fundamentals are similar, but the cloud has its own unique challenges and considerations.
Like what? What's different about securing stuff in the cloud?
Well, first, IAM identity and access management becomes incredibly critical. Managing who has access to what cloud resources.
Because there are so many specific services and permissions.
Exactly. And misconfiguring those roles, giving someone too much access accidentally, that's a huge source of cloud breaches. Really common.
Okay, so getting IAM right is vital. What else?
Configuration in general. Cloud environments are complex. So many services, so many settings. Getting everything set up perfectly securely, especially during a migration, is tough. Easy to leave a door open by mistake. And your attack surface often gets bigger. More services mean more potential entry points for attackers. You need security that scales with your cloud usage.
Makes sense. What about those really new attacks, the 0 days nobody knows about yet? Is the cloud better or worse for that?
It's interesting. For attacks against the underlying cloud infrastructure, the provider, the CSP, often has the advantage. They see threats at scale. They can patch their systems quickly, move customer workloads away from vulnerable hardware.
So they handle the base layer security for 0 days affecting their stuff?
Often, yes.
Yeah.
But you are still absolutely responsible for patching your own operating systems and applications running in the cloud. That doesn't change.
Right. And can you see what's happening on the network as easily in the cloud?
Visibility is different. You get tools like flow logs, traffic mirroring sometimes, but you generally don't get to put your monitoring tools directly on the CSP's physical servers like you might in your own data center. You rely more on the logs and tools the provider gives you.
Okay. And things change so fast in the cloud, don't they? New services, updates all the time.
Constantly, which means your IT and security processes need to keep up. You have to adapt quickly to make sure your security posture stays strong as the cloud platform evolves.
It sounds like a partnership, almost. Which brings us to that shared responsibility model.
Exactly. That's fundamental to cloud security. It draws a line. The cloud service provider, the CSP, is responsible for security of the cloud.
Meaning their data centers, their network hardware, the basic virtualization.
Right. The infrastructure they provide.
Mm-hmm.
But you, the customer, are responsible for security in the cloud.
So my data, my applications, how I configure the services they provide, who I give access to.
Precisely. You secure what you put on their platform. They secure the platform itself. For example, they provide secure building blocks, but you have to configure your web application securely on top of those blocks.
Okay, that division makes sense. Provider handles the foundation, I handle what I build on it. Now, you mentioned cryptography earlier for cloud security. Encryption.
Yeah, cryptography is key for protecting data in the cloud, especially sensitive data. Encryption scrambles your data into unreadable ciphertext.
And you need the key to unscramble it.
Right. Without the key, the data is just gibberish. This protects it both while it's moving across networks in transit and while it's just sitting there in storage at rest.
And managing those keys securely is obviously critical.
Absolutely. Secure key management is paramount. You also mentioned something called crypto shredding.
Yeah. Cryptographic erasure or crypto shredding. It's a way to securely delete data in the cloud. How does that work? Don't you just hit delete?
Well, hitting delete might not truly erase it immediately, especially in complex cloud storage. Crypto shredding works differently. You encrypt the data first, and then to delete it, you just securely destroy the encryption key.
Ah, so the data is still there, technically,
right,
but completely unusable because nobody can decrypt it anymore.
Exactly. It's effectively gone. Irrecoverable. Very reliable way to dispose of data in the cloud.
Neat. And for managing those keys, what technologies are involved?
There are options. Things like TPMs, trusted platform modules, hardware chips, and devices for secure key storage, or cloud HSMs, hardware security modules, which are dedicated secure boxes in the cloud for high security key operations.
Do customers usually handle these directly?
It varies. Often you don't get direct access to the CSP's master keys protecting their whole infrastructure. But most providers let you manage your own keys for your data, either using their services or even bringing your own keys sometimes. Gives you more control.
Okay, lots of layers and tools there. This has been really comprehensive. You said we also had some real-world examples from those security reports.
Yeah, looking at how this plays out in reality is useful. We saw one incident report about a website compromise. It looked like the attackers got in using brute force on an admin account.
Ah, back to brute force.
Yep, over plain HTTP, no less. Yeah. Then they used that access to trick users into downloading malware.
Ouch. What were the recommendations?
Pretty much what we've been talking about. Stop password reuse, make passwords longer and complex, and crucially, add 2FA for admins. Really highlights how basic brute force can open the door to bigger problems.
Definitely drives the point home. Any others?
Another one, a risk assessment, found common issues like old software, shared passwords. Guess what they recommended?
Let me guess. MFA, strong password policies, keeping firewalls updated.
You got it. Same themes. And a third report detailed responding to a DDoS attack, specifically an ICMP flood.
Sending loads of ping requests to overwhelm a server.
Basically, yeah. The response involved blocking the attack traffic, getting services back online, but the future prevention, again, layered defenses, rate limiting that ICMP traffic and using IDS and IPS to detect and block it sooner.
So these real cases just keep reinforcing the need for these layered fundamental security practices.
Absolutely. They show why these things aren't just theoretical best practices. They directly address how real attacks happen.
Okay, so as we kind of pull this all together, this deep dive into network hardening, what's the main takeaway? If someone wants to strengthen their defenses, what's the core message?
I'd say it's really about that multi-layered approach. It's not one silver bullet. It's combining things. Doing that proactive vulnerability checking with VMs and sandboxes, putting strong preventions in place like MFA and solid password rules. And if you're in the cloud, really understanding and owning your part of that shared responsibility model.
And it's not a one-time fix.
Right. Definitely not. The threats change constantly, so you need that ongoing vigilance, continuous learning, reviewing your setup, adapting your strategy. It's a process.
Okay, well, on that note, maybe a final thought for everyone listening. With so much moving to the cloud now, how can you, as an individual or part of an organization, make absolutely sure you're fulfilling your part of that shared security responsibility? Something to really think about.
That's a critical question. And hopefully some of the tools and ideas we talked about today give you a good starting point for exploring what's most relevant for your own situation.